Hello everybody. Can everyone hear me? It's quite a small group today. There's no microphone, but hopefully everyone can hear me. So my name is Richard. I work for a company called Binary, and you can find me on GitHub and Twitter under RichardYoung00. And today I'm going to be talking about unit testing in JavaScript. This is also the only slide that I have. So the rest of this talk is going to be quite informal. We're going to be looking at a lot of code, and we're going to go through stuff quite quickly. So if you need to ask any questions, put your hand up. If I ignore you, throw something at me. Try to get my attention. I'm good at dodging. Okay, cool. Very important. This has to be recorded, apparently. All right, so when you look at testing JavaScript, there's a couple of different options out there. Is anyone writing tests for their JavaScript? That's good. What are you guys using? Mocha. Anything else? Karma. Anything else? Somebody mentioned Jest. Yeah, okay, cool. Well, that's good. All right, so Mocha is kind of like the original, that's one of the oldest testing libraries for JavaScript. But it's been around for a very long time, and it's had quite a lot of development on it. But there's a couple of new players that have come out, namely Jest and Ava. Anyone heard of Ava? It's quite new, but one of the big things with Jest and Ava is that they've got very good sandbox environments for running each test, and they're also really good at running tests in parallel. So there's loads of stories online where people have taken their testing suite down from like 30 minutes to like 11 seconds, and okay, maybe not that much, but anyway, it's pretty good. Like people are getting some pretty positive things out of these two libraries. Jest is actually built off of Mocha. It's pretty much got Mocha and Jasmine and Karma all built into it as one package, so you don't have to go and configure these things yourself. Ava, on the other hand, is designed to be written pretty much from the ground up as something new. It also does some really cool stuff with parallelism and async stuff. But today I'm going to focus mainly on Jest because it's the easiest way to get going with testing stuff. It's got everything that you need built in. You don't have to configure anything, and you can do most of the things out of the box with Jest. So what we'll do is we'll go through a couple of examples of, we'll start with how we'd set up Jest in a project, and then we'll look at some examples of things that we might want to test. Cool, so let's start off with, we've got a project here, npm project. It's got a very simple function in one JavaScript file called sum, which, as the name implies, returns the sum of the two parameters. If we wanted to write a test for this, using Jest, how would we get started? So if we take a look at our package.json, we've got absolutely no dependencies at the moment. So the first thing we're probably going to want to do is we're going to want to install Jest. Cool. This usually can take a little while because, like I said, it's dependent on quite a lot of different things. So while that's busy installing, we can start by creating our first test file. The convention for naming test files in Jest is usually you would say whatever the file is that you're testing, .test.js. So in this case, we're testing the index file, so it's just going to be index.test.js. Jest picks up these files automatically. If you don't want to use that naming convention, you can put it inside a folder called __tests__. If you're willing to go to that much effort to do it, then you can do that, but I personally just prefer to write .test.js, and you can put that file anywhere you want, and Jest will pick it up automatically. I did install this beforehand. This is literally just copying it from a local repository that I am busy running over here. So like I said, it's got quite a lot of stuff in it. When you download this the first time, it usually takes a couple of minutes. Now it'll take about 30 or 40 seconds, hopefully. Unless they released a new version between this afternoon and now, in which case it's going to download the new version. Okay, while that is installing, let's move on. All right, so if we want to write our test, the first thing that we'd have to do is we obviously have to get some sort of a handle on the function that we want to test, right? There we go. So hopefully that's added our dependency that it has. Cool. To run jest, we're going to need some sort of a script. So if we add a script section to our package.json, we just need to tell it to run jest. We don't have to worry about giving it any other parameters or config files. It'll just work. Cool. So if we want to get our function, we can say const sum equals require we can now get a handle on that. And to write our test, very similar to Mocha. Most of you seem to know Mocha. We're going to give it we're going to write a test function that takes in two parameters. The first one is the name of the test. So I'll just say adds 1 plus 2 to equal 3. And the second parameter is going to be the function that actually runs the test. So if you're familiar with Mocha, I think it uses it instead of test. And I'm not sure if it's required, but you would usually have a describe wrapping your test functions inside Mocha. You can do that inside Jest if you want to, but it's not required. It's just kind of a way of scoping your test if you want to add more information to it. But by default, Jest will scope it according to the file. Cool. So once we've got our test set up, we can then use the built-in function expect. And what we expect is that the sum of 1 and 2 to be 3. And using that should be enough for us to get our first test running. Cool. So it ran. We can see that one test passed, and it gives us a nice output about which tests actually passed and the name of the test that we gave it. All right. So in terms of IDE support, WebStorm supports Jest in some of the newer versions. You might have noticed there's a little icon in the gutter over there that allows us to run the test. And Visual Studio Code also has a really nice add-on for Jest that works just by installing the add-on. Works out of the box. Cool. So what does it look like when our test fails? All right. Let me just scroll up so we can see it gives us a nice output where it tells us what the expected value was versus what it actually received. Cool. What if we wanted to use ES syntax? We're not cavemen here. We don't like to use require everywhere. So if we convert that to an import and convert that to an export default, do you think it'll run? Let's try it. No, it doesn't run. And the error that we're getting is unexpected token import. If you've ever tried to use Babel, you might have encountered that a few times. So Jest does support Babel and transpiling your code, but what it requires is it requires you to at least kind of tell it what version of JavaScript we're targeting. Because I mean, it could be TypeScript, it could be ES6, it could be ES7, whatever you wanted it to be. So we need to at least give it some sort of a config to let it know what are we writing this JavaScript in. So all we really need to do is give it a Babel config. And we're going to be using something called Babel preset env. Anyone used that before? It's quite a cool thing. What it will do is try and pick up what syntax you're using and automatically transpile it down to something that's used by most browsers. We have to install it first. This one hopefully won't take as long. So now we haven't actually installed Babel as part of our project yet, but because it's built in as part of Jest and it's picked up that we've put in a Babel config, it's now going to be able to use that, and hopefully we'll be able to run our tests using ES6. Cool, and our test now passes. So what happens if we want to use TypeScript with this? So there's a library called TS.JS, which does all of this for you. It hooks up your source maps so that you can see all of your errors and everything inside TypeScript. It's quite easy to set up. It's just a couple of lines. But if you wanted to use TypeScript, you can do that quite easily with Jest, and it's quite well documented. Two other features that I just want to show you quickly with Jest is we can pass through a parameter watch to the underlying Jest command. So that's what the double set of double dashes is doing. It's just passing that parameter through to the underlying command. So we're essentially running Jest -- watch, and this will start Jest up in watch mode. Watch mode is quite intelligent in terms of it'll only run tests on files that have changed. So each time a file changes, it will pick up which files have changed and which tests are affected by that, and only run that subsection of tests. So you can keep this running in the background without having to worry about what it's doing, and it'll constantly give you feedback on whether you've perhaps broken something in another part of your code. Cool, so if we go to our function, we change that to a minus instead, we can see it's immediately picked up that the test is associated with that, and it's rerun it, and it gives us feedback straight away. Jest also has coverage built into it using Istanbul. Anyone know about that library? All right, so what this will do is it'll run our tests with code coverage and give us a nice table which tells us what percentage of code coverage we have, and it'll even tell you what lines are uncovered so that you can pick up where you maybe need to write some more tests. Okay, when you're running tests from the command line and not from the IDE, it's sometimes a little bit hard to kind of debug a single test. So you've got one test that's failing and you want to run it a couple of times while changing the code, but Jest by default will pick up all of the tests. So if you want to run only one test, you just need to say test.only, and it'll run only that single test. And if you have a problematic test that you want to exclude for now, you can say test.skip. I think there's similar ones in Mocha as well that do the same sort of thing. All right, cool. So in this test over here, we're using a function or a helper called toBe. And this comes off of the matches that are built into Jest. What this does is it delegates to the function object.is. Does anyone know what that does? It's pretty much the same as your equality. If it's a primitive data type, it will check if they're the same value. If it's an object, it checks if it's the same object reference in memory. So that obviously doesn't help us if we want to start testing more complex objects. So let's take a look at another example. Here we've got a function called addTotal, which takes in a price list. And the idea is that the price list just has a list of items with numerical values. We want to add up all of those values, and it'll put a total onto that same object for us. So the test for this, I'll just go through it, is we've got a price list, for example, with eggs, milk, and bread. We want to say addTotal, and we now expect the result to be the same thing, but it's got an added total on it, which is now everything added up. So we can't use toBe because it's objects. So what we can use is another matcher built into Jest called ToEqual. And this is essentially a deep equals. It's going to take each item on our object, and if it is an object, it's going to recursively go in there and then check each item on that one. It's going to keep going and check that everything on the object is the same. It's essentially the same as a lot of people will do like a object.stringify or whatever, JSON stringify, and then parse it again to create a deep copy. It's kind of like that, but it's a little bit more efficient, I think, than that. All right, cool. Let's just check that this test runs. All right, cool. So that ToEqual also works on arrays. If we wanted to compare if two arrays are the same, we can also check that. But what happens now if we were to swap elements around in these arrays? Let's say we had it like this. Do you think it would pass? All right, so it's failing because it's checking the order of the items as well. What happens if we didn't care about the order? Our test actually doesn't care about the order. How would we test that? Any ideas? You could sort it, but there's an easier way, thanks to Jest. So we'll use another matcher called expect.arrayContaining. And essentially what we're doing here is we're saying we don't really care about the order as long as all of these items appear in that array.
What would happen if your first array had more items?
In array containing.
Yeah.
Wait until the next example and see. You'll never believe what happens next. All right, so as Jerry alluded to, this is also very useful for testing subsets. If we only care that there's one or two elements in that array, array containing, it's pretty much think of it as like looping through the items and checking that that item is contained inside the array. So this should work, and so should this. I swear these tests were running faster earlier. Okay, so this array containing is quite useful, but something that's even more useful is we can do the same sort of thing with objects. There's another matcher called objects containing. So when we're busy comparing objects, if we only care about one or two items on the object, we can use the expect.objectsContaining. For example, here, we only care that A and B have got that value. C can be absolutely anything. We don't care about it. It's not part of this test. And this really helps when you're trying to write specific tests that are only trying to test one thing, and you don't really care about what C is doing because that's being tested somewhere else. The real power of matches, though, comes in combining them together. So over here, we've got an input array, and in this array are a list of objects, and each object has a name. What we want to look for is we want to look for objects inside this array that contain the name Wally, like from Where's Wally? That's the thing, right? So here what we can use is expect input to contain equal. It's to contain equal and not to contain. The equal part means that we're actually going to dig into the object to look at its fields. We're not going to just compare the memory addresses. And we want to look for an object containing Wally. Make sense? We can then take it one step further, and let's say we want to support the Americans who call Wally Waldo, apparently. And instead of just looking for where the name is Wally, we can now look for where the name is a string containing Wally. We can chain as many of these things together as we want, where we can build up infinitely complex matcher to test things. Okay, so one of the things that's usually quite difficult to test is asynchronous code. Why is it difficult to test asynchronous code? Yep, exactly. So what happens is we start off some asynchronous code which goes off and does something. Our test carries on and completes. And by the time this code returns to us, our test is already done. It doesn't know what the result is because this thing has already gone off and done whatever it was doing. So here are 3 examples of things that we're going to look at how we would test: a successful promise, unsuccessful promise, and a callback. So if we look at the successful promise first, it's quite easy for us to just say that we expect the successful promise dot resolves to be success. That dot resolves that comes from Jest is actually just syntactic sugar for doing dot then and then taking the value and passing it to the next function along the line. But it makes it quite easy to read as a human to know exactly what's happening with that. I'll run the test to prove to you that it works. little bit to prove to myself.
So does that actually call the promise?
Yeah, so that actually calls the promise and captures the result. You can see here this promise is saying .resolve success. So we're now expecting that whatever comes out of that promise is going to be success. If it's a more complex object, you'll probably use a more complex matcher to assert that.
Observables? They're like promises.
Let's chat afterwards. So I've tested observables. It's a little bit more complicated. We'll use the last item on this list. It's similar to callbacks. All right, cool. So unsuccessful promises, as you may have guessed, is very similar. We're just going to say .rejects and make sure that whatever it's rejecting with is the right value. In this case, it's fail. And now callbacks. So callbacks are a little bit different, right? We don't really have a way of being able to say .then or kind of wait for a callback to return. So what Jest does, actually what Jest stole from Mocha, is another way to write your test where it takes in an argument called done. And done is a function that we will call at some point during our test, and we're pretty much saying the test is not done until we say so. So what happens is if the done function is not called within 5 seconds, the test will fail. That's obviously quite a high amount of time. If you have 1,000 tests that are taking 5 seconds to fail, it's not good for how long your test suite is going to take to run. But there isn't really another way to do it. We can fiddle with that timeout if we want to. If we know that it's going to be quite quick, we can move it down to like 2 seconds or 1 second. But essentially, we have to implement that callback, and once the callback has done its assertions, we can then call done on it. If we don't call done, it should time out. Because it took 5 seconds to start the test and then 5 seconds to time out. All right, cool. So we can see that it timed out like that. So with observables, you would have to use something similar to this. Additionally, what you have to do is you have to tell it to expect certain assertions. So what we could do here is, I think it might just be expect assertions. I can't remember the exact syntax. But you're pretty much telling it that we're going to do at least one assertion inside this test. And if you don't get to that assertion and you've gone through the whole test, then you should fail. So by default, if you don't do any assertions in a test, it just runs through and passes. We're telling it to look for an assertion. Then what you do with your observables is you need to convert your output to an array. And then inside your observable, you would start doing your expects. But you'd also have to set your expect assertions to at least 1 to make sure that you get to that point. If you find a better way of testing observables, I'd be quite keen to talk to you. All right, so the last thing is that Jest also supports the async await syntax. I haven't got an example here because the next couple of examples are going to use that. All right, so yes, kind of. But we're using the syntactic sugar inside the test instead. So usually when we're doing something asynchronous, it's because we're doing something that takes long or something external to our application. So we're downloading a file from the internet, or we're reading a file on the disk, or we're connecting to the database, something that takes a bit of time. And that kind of stuff is not the kind of stuff you want to do inside your tests. Firstly, because it takes time. Secondly, because it's not very repeatable. If you don't have internet access, then your tests are going to fail. Or if you're not connected to the prod DB, your tests are going to fail. Or even worse, somebody's going to write a test that does something to your prod DB. So that's where mocking comes in. Now, the idea of mocking is that we're going to take something that would usually... Am I standing on the cable? Is that what it is? Looks as though standing on the cable is what made it work. Let me try the Chromecast again quickly while it's here.
Sorry.
Wait, it's working, it's working. Can we take this out?
Yes.
All right. Okay. So this example, we've got a function called getUserGreeting, which is going to use a library called Axios, which is quite popular for making AJAX calls. Okay.
What's happening?
Just restart it. Okay. You might have to just let me know when that happens so I can fix it. Okay, so Axios is quite popular for making AJAX calls. We're making a GET call to that URL, and we're doing some kind of processing with the response. Cool. So if we wanted to test something like this, we wouldn't really want to be making that call to that URL because, like I said, time-consuming. We don't know. We're not in control of whatever's on the end of that URL. They could change that data, and our test will fail. All right. So I've set up our test here. One thing we know for sure is we're going to have to call that that function, and you can see here I'm using the async await syntax. The first thing we're going to need to do is we're going to need to tell Jest that we want to mock out Axios. So it's now going to create a mock function of Axios, and anything we do with Axios is now going to be rerouted to Jest and not routed to the real library. Then what we're going to need to do is we're going to need to tell Jest that when we call get on Axios, we want to mock the resolved value, and that's what we wanted to return instead. If it wasn't a promise, this is returning a promise, it would be mock return value instead of mock resolved value. So it's just sort of syntactic sugar for saying we want a promise that's going to resolve rather than a promise that's going to reject. And when it resolves, give us that data. Sorry?
So if your function is expecting a callback, how do you mock that response?
When you pass in the callback, you would pass in a mock function. So we can create a variable like this. That's essentially a mock inside Jest. If we wanted to tell it to have a certain implementation, we'd pass that through as a parameter. So we could say the implementation of this is actually that. You know, that's the implementation, but it's still a mock object. And mock objects are quite powerful. I'll show you at the end of this some of the other cool things we can do with mocks. All right, cool. So then we can do an assertion on the return value, and we obviously expect it to be Chuck Norris. I promise that URL is not returning Chuck Norris. But because we're mocking out the data, it should pass. Awkward silence. It's important when programming to have awkward silence. All right, cool. So the test passed. And because Axios is a mock function, it gives us a couple of other things that we can do with it. There's something called spying. Now, there's another library that does spying. I don't remember. It's not Chai. It's one of the other ones. Sign on. Yes, there we go. Sign on. Does it? All right. So I don't know which one of those things Jest is actually using under the hood. Like I said, it depends on all of them. So it might be using a combination of them. But here what we can do is we can say that we expect Axios.get, which is the function, to have been called with, and then give it parameters. So here what we're doing is we're kind of asserting that our mock was actually called with certain parameters. Now that's really powerful if you have functions that you need to test that don't actually return values to you. Like think of saving something to a file. Like you're calling the save method, but it's not really returning anything valuable to you. But you still want to check that the internals of that function are doing what they're supposed to do. Okay, so who has used Express here? Quite a few of you. So this should look, not this, this should look a little bit familiar. We're setting up a very basic Express app, and we're saying that we want to get on /users, which is going to return us a JSON object where name is Chuck Norris. I feel like people have stopped Chuck Norris jokes. I'm quite sad about that. So how would we test something like this? I mean, there's not a huge amount of logic happening in this particular thing, but I mean, let's say there was some more logic. How would you test it? Any ideas?
Well, yes. Use SuperTest.
Good answer. What most people try and do is they try and extract the logic into like another function away from Express and try and test that function in isolation and then just leave Express to do its stuff. But using SuperTest is actually a really easy way to test APIs quite quickly. So SuperTest will spin up a very fast, very small test instance of our Express app. You can see over here I'm importing request from SuperTest. I'm then passing it the app, which I've imported from the index file. And it then gives us a way to call our REST endpoints off of that. So we can then say .get/user, get a response from that. That returns a promise, so we're going to use async await again. And then we can run our assertions on that response. And it's quite easy for us to test very simple API stuff. So SuperTest also has a number of other very powerful things built into it, like cookie storage. So you can test your persisted sessions as well as authentication. And it even has the ability to simulate like multi-part uploads. So you can test uploading files to your endpoint without ever actually needing to upload a file to it. A couple of caveats to think about when using SuperTest is it's actually spinning up an instance of your app, right? It just so happens that Express is quite lightweight. But if you happen to have lots of middleware on your Express app and it takes a long time to start up, your test is going to take a long time as well. It is possible to kind of split out your middleware or test your middleware individually so that you don't have to have everything start up all at once. The other thing is that it starts it up on a port that it chooses. I think it's like 50,001. But Jest runs your tests in parallel. So if you're running multiple of these tests at the same time and it's starting up different instances, they're going to start clashing on that port. You can override that port and kind of just make it different on each one. But it's just something you need to think about when you're using SuperTest. This is kind of more of an integration test, so you're not going to have a huge number of these tests. But it is a really easy way to test your APIs. Yeah, so it definitely is. I mean, if we take a look at this index file over here, let's say that this function called a database and then returned a value from that database. From our test, we can inject mocks into this index file over here. So we could mock out the database and then call SuperTest, and then it would then fetch data from our mock database. All right, cool. So most of what we've done so far has been pure JavaScript. We haven't interacted with the DOM very much. But that's not what JavaScript is for. JavaScript is for interacting with the DOM. At least that's what most people use it for. So I'm going to show you a quick example using React. The same thing applies to all of the other frameworks. I'm just most familiar with React, so that's why I made the example in React. But you could do this with Angular and Vue and any other component-based program as well. Cool. So Jest by itself, people often think that Jest is a React testing framework. I'm not sure where that came from, probably because the Facebook team maintains it. But it was never designed to be a React-only thing. It's completely framework agnostic, although all of the examples are written in React. But that's probably just because it's the Facebook team. But you can test pretty much anything on it. You don't have to stick to React. So in order to actually test a React component, we have to use another library called Enzyme, which is, as far as I know, React specific. I think it only supports React, but there are alternate libraries that work for all of the other ones. So let me show you quickly what this app does. Very simple. It's just going to render my component, and my component has got an input box, which is going to capture somebody's name. It's got a button, and when we click that, it's just going to say hello, and it's going to print out hello, whatever name you've put in there. So I'm running this this application with Parcel. Has anyone used Parcel? It's kind of like an alternative to Webpack. It's apparently really fast. So it built this application in less than a second. Usually React, or Webpack at least, will take like 2 or 3 seconds to build that. All right, cool. So here is our amazing app. It doesn't play music, unfortunately, but we can enter our name, click say hello, and it prints out our name. All right, so that's very basic functionality, but how would you test that? The usual way to test this kind of thing is like spin up Selenium, WebDriver, let's get this thing going, go find a button. No, wait, the button hasn't rendered yet. Wait 2 seconds, then look for the button. That's not really a good way of writing unit tests. That's more kind of like your end-to-end tests, and it's quite brittle. So what we can do with Enzyme is we can mount these components. So I'll show you firstly. I've set up Enzyme here because it can be a little bit tricky to set up at first. It requires a separate adapter for different versions of React. Don't know why it does that, but anyway, it's pretty much this line over here that we need to configure. It also gives us a function called mount. I'm passing through the components, and then I'm just saying .html. I'm going to log that out quickly, just so that you can see what that looks like. But it's essentially going to log out the HTML of our component as if it was rendered to the DOM. So this isn't virtual DOM stuff. This is when it actually hits the browser, this is the HTML that we're going to see. Cool, and you can see over here, doesn't look great, but there's our HTML that gets rendered out. Instead of just rendering, logging that out, what we can use is a feature of Jest called snapshot testing. And essentially what snapshot testing does, let me start it so long, because it might take a while, is it's going to capture a snapshot of our components as they are now. It's going to take a snapshot of that same HTML that I logged out, and it's going to save that in a file for us. So the first time we run it, it's actually not testing anything. It's just creating that initial file. Did it run? You can see it's created a folder called Snapshots over here. And this file has just got the name of our test along with the HTML that rendered. When we run this the second time, it's now going to compare that HTML to the one that we've got saved on disk. So this is really good for picking up regressions. When somebody changes something that affects your components, including styles, we can now kind of pick up when we get regressions that start interfering with our component. Now, obviously, you don't really want to do snapshot testing on components that change quite frequently, because it means that every single time you run the test, something's going to be different, and you're going to have to go and update your snapshots. All right, so if we change this to say hi instead of say hello, run the test from here, it should fail because it no longer matches the snapshot. It doesn't give us great output. It's pretty much giving us a diff of that whole HTML string, but at least we know that something's broken. All right, what happens now if we've made a legitimate change and we want to update the snapshot? Well, we can pass through a flag to it, -u for update snapshots, or you may have noticed that WebStorm has given us a nice little link, which will just run that command for us. And that'll update the snapshots for us. And we'll have to commit those changes into our source control. So I've heard some horror stories about the snapshot testing not working so well, specifically giving different results depending on the operating system that it runs on. So those are things to be aware of. Again, it's not something that I would use that often. But if you've got a component that's pretty well solidified that you know is used throughout your application, it's maybe a good idea to add a snapshot test if it's not going to change very frequently. All right, so Enzyme is not just good for rendering the HTML of our components. There's some more stuff that we can do with it. If we don't call .html on our component, what we get is some kind of a wrapper, which is essentially a mounted component with a virtual DOM and everything. What we can then do is say component.findInput. So we're looking for that input box. We're simulating a change on that input box, and we're giving it a value that we want to insert into that input box. So this is pretty much the same as going in and typing a value into the input box. We can then look for the button and click it. Lastly, we can just get the text of that component. That essentially looks for text that's not part of HTML. It'll strip out all of the HTML stuff. And we can make sure that somewhere on that page is the text, "Hello Richard." Cool, so what we've done is we've essentially done almost like a Selenium type test, but on a single component, just testing the small part of functionality of it. There's no asynchronous stuff here that's going to break if it doesn't find the button, or the button hasn't rendered yet. We don't have to do any kind of waiting or timeouts to make sure it works. This is all synchronous, and it's pretty much guaranteed to always work or always fail. Another thing that we can do with Enzyme is we can actually dig into the state and props of a component. So, for example, inside that component, I'm setting a value and state called name when we enter data into the text box. So we can actually assert stuff off of the props and the state of that. Cool, and it passes. All right, so that's all good and well in a nice, well-established framework like React. But what happens if we have some code like this? This is a index.html file. It's got an input and a button. Looks quite similar to our previous example. And if we run it, it actually looks exactly like our previous example. And it does the same stuff. It's just done in jQuery instead of React. Cool, at the bottom of this we're importing jQuery, and we're also importing a sayhello.js, which looks like this. Now this is like less than a quarter of the size of the React thing, so I don't know why we use React when we can just write code like that.
Yeah, sometimes. It's going backwards.
But it's essentially doing the same thing. It's just looking for the value in the input, putting it in the output, and appending hello on the front. Okay, so how on earth do we test this?
Same one.
So we don't have something like Enzyme, because nobody writes stuff like that for jQuery.
It's for jQuery.
Yeah, pretty much that's what most people's response is why are we even bothering? Just get rid of the jQuery. So there's some cases where you can't get rid of jQuery. I speak from experience. I have at least one jQuery plugin in production, which I'm not proud of, but no one else makes anything remotely similar to that. Okay, so the secret to testing something like this is built into Jest. What it actually does is it uses something called JS DOM. Is anyone familiar with that? It probably took at least 10 of the seconds when we were busy installing Jest in the beginning. It's quite a big library, but it's essentially an implementation of the DOM written in JavaScript. The name kind of gives it away. But JS DOM allows us to run a headless browser. Anyone familiar with headless browsers? And this is actually built into every test that Jest runs. So if we put in something like that, I mean, that looks completely absurd. Like, where does documents exist inside a node test? But it's because we're running JS DOM, there's actually a document available to us, and we can set the inner HTML. And it's quite easy for us to just set it to that index.html. But one caveat is that by default, JS DOM does not run scripts inside HTML. So when we import that, we had a couple of scripts at the bottom. It's not going to import that for safety reasons or something. I don't know. So what we'll have to do is just import those ourselves. So to set our global $sign for jQuery, we need to say global.$. That's a Jest thing as well. I'm going to say require jQuery, and we're also going to need to require our JavaScript file. And because we're using jQuery anyway, let's just use it in the test. So let's find that button with ID name, give it a value, the input. Let's find the button and click on it. Get the text from the output, and then we can do our expect. But will it run? It builds suspense, actually. It's quite good. Cool. And it passed. So let's say we didn't have the luxury of having this external file that gets imported. Let's say we had our script literally hard-coded into this HTML file. What we can do is we can actually use JS DOM separately. And we can tell JS DOM to load up this file, and we can pass in the right flags to tell it to actually go and execute that JavaScript for us. That's pretty much the only way we'd get it to kind of fully load this file. I mean, it's a headless browser, right? It should be able to load HTML and JavaScript. But once that's loaded into JS DOM, we can pretty much do all of these same things over here. All right, cool. That's pretty much everything that I was going to go through. I rushed through a lot of it. Are there any questions or things that anyone wants me to go back to?
It's just like curling, but does it work in IE?
It doesn't need to because it's working in JS DOM, right? So this, because it passes in JS DOM, does not mean it passes in IE. So JS DOM is a browser by itself.
React one.
Yeah.
So
jQuery.
Jest comes in with a whole lot of functionality built in, and I guess that's why it took so long to sort of install. Is there a way, for example, if I know I'm not going to be using promises in my test, is there a way to exclude that sort of portion that I can only deal with, callbacks, for example? Or is there a way just to get a certain portion of that Jest library that I know that I need, but I wouldn't use anything else?
Yes, but I don't know fully. Let me see if I can find it. So Jest is actually made up of a number of different packages. And those packages are all available separately. So for example, there's a specific package that just looks for code that has changed and finds the appropriate tests to run on it. So if we have a look at the source code of Jest, under packages, there's a load of different packages here. And you could import each one of these individually. So I'm not sure how many of them you'd actually need to import to get like a working Jest version. But there's quite a lot of them that you'd be able to use independently without needing to get the full Jest kind of environment. And probably if you use something like a Mocha and just included some of these things, you'd get halfway there. Any other questions? Comments? Insults? Cool. Thank you.